So chapter 29 is about one of the weirdest, funkiest types of physics, quantum physics. And just a review of some of the equations and where they come from. And then I have a little physics simulation to do on PhET. And we're going to watch a little video about quantum physics and how it's actually used. I'm going to start with chemistry. How many of you have taken chemistry? Did you take chemistry in high school? This is like high school chemistry stuff. So I'm going to draw a picture, and you're going to tell me what it's a picture of. Or we'll see if you can tell me what it's a picture of. Okay. I'm such a good artist. Well, chemistry is probably the place where you'd study this. What is this in chemistry? What is Jenna? Say it louder. It's an atom. Yep. Okay. What's in the middle of an atom? Nucleus. And what's the nucleus made out of? Protons and neutrons. So what's the charge of the nucleus? Positive, negative, neutral? Positive. What's the charge of protons? Positive. Charge of neutrons? Neutral. So overall, the middle of the atom is positive. Great. And what are the circles on the outside? Electrons. Right? We stick electrons in here, and these electrons, they orbit around, right? Okay. So something in quantum physics that we found was actually these electrons, they orbit in a cloud. So they're not in these specific levels, but actually they kind of are because energy of electrons, they can only be in these specific places. When we measure an energy of an electron inside of an atom, it only appears in these specific levels. So this first level we'll call n equals 0. We also call it an orbital, n equals 1, n equals 2, all of that stuff. Do you remember any of that from chemistry? You remember that from chemistry? Okay, good. And those orbitals mean stuff, and there's quantum numbers that we use to describe stuff, all sorts of useful things we can do. But what we're going to focus on here is the energy of one of these levels is n plus 1/2 times h times f. Where f is the frequency of light that will let this electron jump up some level. So maybe there's a piece of red light that comes in and smacks into the electron. The electron absorbs that piece of red light and it can jump up a level. Maybe there's a piece of blue light that comes in, smacks that electron, and that electron can jump up 2 levels. The amount of energy that you're using to jump levels inside of the atom is this equation right here. Okay? So that means that the change in energy inside of an atom is equal to some fraction of h times f. Something like this. Okay? So the big focus of this is called quantization of energy. And this was found by physicists, and this was a big mystery. This was very weird. This is weird because of what we've learned in previous chapters. Anybody remember what the energy of a wave is? What's the equation for energy of a wave? Energy of a wave. Let's go back to the wave chapters. Energy of a wave is h times f. Does that look familiar? Yeah, it's the same as the energy of this. We got a wave, but then E equals NHF. What is that the energy of? It's the energy of something jumping up and down. What's jumping between those levels to give us that energy? Electrons. So this is the energy of an electron. This is really weird for physicists. It's like freaks them out. It's terrifying. Because electrons are particles. Electron is a little particle. We can measure them, we can find them, we can see them. But this is the energy of a wave. So this says that electrons are particles and waves. Freaked people out. Very weird. Then along comes this guy. Let's see. You recognize this guy? You know Einstein? Einstein comes along and he wins a prize. What's the biggest prize in science? What's the biggest prize you can win in science? Nobel Prize. Do you know how much do you win for winning a Nobel Prize? Biggest prize in science. Like people are like, oh, I gotta get the Nobel Prize. What's it worth?
$0.
No, they got money.
$10.
No, more than that. What's that? I guess this isn't going to be shocking. It's what? $1 million. They win $1 million for winning the Nobel Prize. That seems pretty low to me. It's groundbreaking science nobody's ever heard of, and huge discovery, and here's $1 million. I think about the cast of Friends, and they made like $1 million for 10 minutes in an episode. It's crazy. So Einstein came along. He won the Nobel Prize. What did he win the Nobel Prize for? Anybody know? For exactly what you're learning. Good guess. And that's called the photoelectric effect. And at the time, people thought Einstein was a freaking moron. Because he came along and he knew about this energy of a wave, that electrons were particles and waves. So he said that light is a particle/wave. He said light is a wave and a particle. He said light is both. That was weird. Everybody else at the time said, oh, light, definitely a wave. Einstein said, light is actually a particle too, and we're going to give that a name. We're going to call that a photon. Particle of light. We learned about that. Einstein said this, won the Nobel Prize for it. And there's an equation that lets us say this. The equation he figured out was Ke equals HF minus BE. Now let's draw a picture of this. So we could do this experiment. Anybody, you all have cars, yes? Do your cars have daytime running lights? Lights that stay on during the day? They work by this photoelectric effect. Right? This is the reason that they work. So what the photoelectric effect does is it tells you energy of electrons that are going to jump across this completely empty space. And the energy of the electrons that can jump across this empty space is equal to HF, which is the energy of light that you're going to shine onto this little plate, minus the binding energy, which is how much energy they're glued to this plate with. So this plate has a certain amount of energy that keeps the electrons on it, and as long as you shine energy onto this plate that's bigger than that energy of the glue, the electrons can jump across, and you can get charge actually flowing. You can get electricity moving through empty space. It's pretty useful. And what Einstein did this experiment, he's shown a whole bunch of red light, a whole crap ton of red light. That's in the manuscript he wrote. This is a whole crap ton of red light. Whole bunch of red light. And nothing happened. And then what he did, he shined just one little tiny piece of blue light and immediately had stuff flying. That experiment, that's the photoelectric effect, that led to this equation. And that's what you're going to do in the lab. You're going to play with that photoelectric effect and shine some lights and see how it works and see little electrons jumping around. Okay, big experiment, super, super important for all of physics. Won a Nobel Prize. So the big point here is that electrons are particles and waves. Photons. What's another name for a photon? What is a photon? Particle of what? Light. Photons are light. Are particles/waves. And what it turns out, we think, in physics, everything is particles and waves. These two really, really weird things. You are a particle, bunch of particles, right? That makes sense. But you're also a wave. What this means is everything in the world is a probability. There's a non-zero chance that anything can happen. So we've done experiments to kind of prove this. Some thoughts result in this, some weird thought experiments. So if I stand up here at the board and I just keep tapping the board and just stand here and forever tap the board, there is a probability that my hand, the atoms in my hand will align perfectly with the atoms in the wall, and my hand will actually go through the wall. And mathematically, physically, there is some parallel universe where one time when I put my hand up against the board, it actually goes through. So this leads us to probabilities, which result in the multiverse. Have you ever heard of the multiverse? Parallel universes, multiple universes. Quantum mechanics predicts this. It also predicts this with something called Schrodinger's cat. Have anybody heard of Schrodinger's cat? The concept of Schrodinger's cat. So this is an experiment that you can do where you take a box, and inside of that box you put a really doofy looking cat. Okay? And then you seal that box. You close the box up, and inside of that box you put a little tube, test tube of some sort, and inside of that test tube there's a deadly gas. Okay? Sound like a nice experiment? No? Test tube is made of glass, and you don't know if the test tube is broken or not broken. If the test tube's broken, then what's going to happen to the cat? Releases the gas and the cat dies. If the test tube's not broken, what happens to the cat? Cat's still alive. So Schrodinger's thought experiment, is that until you open this box, you don't know what's happening with the cat. The cat is alive with equal probability to it being dead. There's a 50% chance the cat is alive, a 50% chance the cat is dead. So this actually splits off into two different boxes. One where the cat's alive and has changed his shape, and one where the cat is not alive. And quantum physics says each of these are equally possible to happen. Until you open the box, you don't know. So, as long as you don't open the box, the cat is both alive and dead at the same time. Okay. What do you call something that's alive and dead? This is a zombie cat. And then if you keep going with this, what happens to the cat that's alive? Let's say you open the box and the cat's alive. What do you then do? Because you're a horrible human being. You repeat the experiment. So you, cat, alive and dead, cat, alive and dead, cat, alive and dead. And it keeps spitting off and keeps giving you more and more universes. So you get the multiverse that way. Okay. Everything's probabilities. Other probability, something called the Heisenberg uncertainty principle. Anybody ever seen Breaking Bad? What was his name? What did he call himself? Heisenberg. It's after this. This is the guy that he named himself after. And this is also how you can get out of speeding tickets. Okay. Heisenberg uncertainty principle. So the way this works is you treat everything as a probability. So what that means is you don't know anything exactly. Right? I don't know the exact answer to anything because everything has some wave, some probability. So if I measure how big this is, it always has some uncertainty with it. This might be like a foot plus or minus a couple centimeters. Okay? So anytime you do a measurement, you don't know the exact value, and we can quantify that with this equation. Delta x is how well I know where something is, times delta p. What was p from physics 1? Do you remember? Momentum. What is the equation for momentum? What does momentum measure? Mass and velocity. Okay? And this value, I think of it as delta x is a position, delta p is a momentum, but it's really a speed. So how fast something's going. That value is always greater than or equal to, let me get you the right value, h over 4 pi, where this h is the same one as the energy equation. It's called Planck's constant. But delta x, delta p is greater than or equal to h over 4 pi. So what this means is you cannot know an object's position and its velocity to infinite precision. So how do you use this to get out of a speeding ticket? Okay. So, cop comes up to your window, and what do they ask when they pull you over for speeding? Do you know how fast you were going? So the physicist's answer is, no, but I know where I am. Did you get it? This is a joke that I was told in graduate school. Cop pulls somebody over, asks you, do you know how fast you were going? You say, no, but I know where I am. Okay. If I know where I am, if I know what delta x is, if I know exactly where I am, what's the uncertainty in where I am? If I know the exact value, if I have no uncertainty, then the delta x, if I know exactly where I am, is equal to 0, because I know the exact position. 0 times some number has to be greater than or equal to h over 4 pi. What is 0 times anything? 0. There's only one number that you can multiply 0 by and get something bigger than 0. Did you know that? Blows my mind. There's one number you can multiply by. 0 is the smallest number. What's the biggest number? It's the biggest thing you can have. Do you know the biggest thing you can have? Do you know what this is? What's that? You said it? That's infinity. Okay, so infinity, if I know where I am, if this is 0, this has to be infinity. So the uncertainty in how fast I was going is infinite. That's what counts for a joke in physics. I can see you all love that joke. Okay.